for joining us this afternoon for our second workshop in a series of three that Dr. Jacob Kirksey is putting on for us for the True Scholars Program on educational policy research. The first workshop was mainly kind of an overview of education policy research and some of the intersections that it has with our life in general. And so this workshop is more hands-on based skills and things like that that you would that will be incorporated in education policy research. So if you didn't join the last one, Dr. Jacob Kirksey is an assistant professor in educational psychology, leadership, and counseling in the Texas Tech College of Education. And I'll hand it to him.
Great. Thank you so much, Jeremy. Hello, I'm excited to introduce you to some of the hands-on aspects of some of the research that I was talking about in my last talk. And this is very hands-on. So we're going to be spending this entire workshop kind of how I spend a lot of my day sometimes, looking and managing data in statistical software. So some of the things that you will need will be provided to you if you're watching this as a recording via some links, but I'm also, for those who are participating now live, I'm going to go ahead and add some links in the chat. So the first link is a OneDrive link where you can download the sample data sets and lab handout that we will be working on today. And then the second link is going to be a link to something that you can do in the future when you try to adopt and use some of this stuff on your own. It's a link to the software program's website where you can request a free short-term license, just get your hands dirty working and playing with data. So I'm going to go ahead and share my screen. The first thing you should see is this is that second link, the website to Stata. It's very easy also just to Google Stata student short-term license. They allow you to request this license and approve it pretty quickly for you to work on for up to a week. And this can be for courses or just to try things out. But then student licenses in general are fairly inexpensive. I believe you can get 6 months for about $47, so less than a textbook. And it can do pretty much everything you need. So this is what Stata looks like, and this is the software that we're going to be using today. I thought a lot about whether I wanted to go down the route of teaching a lot of this stuff I wanted to talk about in Excel, but really the tangible skills that I feel like undergraduate and even graduate students I work with benefit from and gain really quickly is working in statistical syntax that is later applicable in other software programs as well. And Stata is a very user-friendly syntax language in my opinion. And I think you'll see that today. So I'm going to go ahead and go to my folder where all of this stuff is stored. So that first link to the OneDrive, you should be able to see 4 different data sets. I'll talk about what these are in just a second, but then you also should be able to see the lab handout, which is what I will be using as we walk through the activity together today. So first things first, once you have all these materials downloaded, then you can open Stata. And this is just a brief kind of overview of what you're seeing here when you open Stata. Your stuff will look just slightly different. I think I have mine in dark mode. That's an option when you go to install it, but if you didn't select that option, it should be a light blue and white. And then I have a slightly different version of Stata than you will probably get if you download this in the near future. So this is generally what Stata looks like. This is the software program that if you were to be working with me, or actually a lot of researchers in education policy, this is largely the software that I think dominates our field in terms of what we use. You may have also heard of R or SPSS. Some of you may have even heard of MATLAB and things like that. Those are used in our field as well in education policy research, but I think Stata is the primary software. And I also think for those of you who are new to coding, not to scare you off at all, because I was brand new to coding when I was in my PhD program, I think Stata is a really gentle introduction to that. So that's why I've chosen it, and we'll focus our hands-on workshop today going through Stata together. So here's the interface of what you should see. Again, it may look slightly different, but there are some key windows that I want you all to just kind of become familiar with. You have generally the results window right here shown by results. And this is where you're going to see all the output that you get from the syntax that we work with today. You have a window over here called variables. And this is when you have data loaded into Stata, where you will see variable names and any labels that the variables have. You have properties over here, which generally tells you the properties of the data set that you've loaded in to Stata, including the name of the data set, any labels that the data set comes with, types of the values of the different variables, such as strings and numeric, and I'll get into that even more in just a second. And then you have your command window. And your command window is where you can type in the syntax directly if you would like, but as I will introduce this now, I much prefer that we work through a do file together because a do file is an accurate log of all the syntax that you have written up, and you can easily go back and reuse at any given point in time. And so the first things first, if you didn't see what I just did there, I want you to go to the top center menu over here where you see a little, it looks like a piece of paper with a pencil. If you click on that icon, or an alternative thing you can do is you can go to File and New and open a do file that way. So you're going to get something that just looks like a text editor. If you are joining us live today and you don't have Stata installed, you can also just open up a text editor on your own laptop or Microsoft Word, whatever you think makes the most sense for you to kind of preserve and go back and use in Stata at a later point, because really that's all this is a text editor that just talks directly to Stata. So I'm going to pull up an old do file of mine just so I can get some of the initial settings that I like to set up for us. Oops, and then I need to open up a new do file again because it just got rid of my old one. So the first thing I like to do, and this isn't in the handout up until we get to this point, is I like to just keep an accurate log of what the project is I'm working on and things like that. And so, like I said, everything that you put in this do file is going to read into Stata. And so Stata does not read English per se, or at least not in the same way that we think about writing and reading in English, right? It's a different language. And so anything that we just want to annotate and keep notes of, we can do that with a couple of different features. So one, let me just go here, and you can see now this changes colors because now Stata is going to try to read this as syntax. I like to keep just an accurate kind of titling scheme, and you can just kind of box text that you don't want Stata to read with this slash and star asterisk symbol, and then asterisk and the slash kind of in the inverse way when you're done telling Stata to read stuff. So I like to give the project a name. So I'm going to call this project for us Intro to Stata and Data Management. I like to actually go ahead and save our do file and give it a name. So I'm going to call this do file workshop 2. I'm going to highlight this old name I have, just add workshop 2. I like to write out all the data sets that we're going to be using today. So you can see as you downloaded them earlier, they'll be using the students 2017, the students 2018, and the students 2019 data set. And then we also are going to be using the assessments. I forget the full name of it. It's assessments all underscore 2017 through 2019. We'll go back and fix some of this. All right, and then the data set that we will be saving here, I'll come back and edit this later. Go ahead and write your name and today's date. So the first thing, let's go back to our handout. This is going to be what we use to kind of guide us through today's workshop. We've already loaded up Stata and created our do file, so we're done with step one. The second thing we're going to do is right up at the top. So for me, that's line 13. We are going to hit clear. We do that just because we want our do files at all time to be able to start from the beginning and end without any error. And so you'll see me try to run this do file over and over again in today's workshop. And so this having clear at the beginning is just one way for us to ensure that Stata is clear of any data, so it doesn't error out and think that we're trying to override data when, by mistake. So the second thing we're going to do, and this is always the trickiest part. So you may have to rewind the recording a couple of different times and to do this, but we are going to set up our directory macro. And so the directory macro tells Stata where our data are going to be located throughout the entire workshop. And so you downloaded those 4 data sets from the OneDrive folder already at this point in the workshop, right? So now I encourage you to just put those files in a place that you will remember and archive away on your computer so that you can always come back to this at a later point. And then what I need you to do to find the workshop is I need you to go ahead and give this workshop or find this folder that you just stored that data in. And if you're on a Mac, all you have to do is just click on the folder itself, and Command C, and it's going to give you a file pathway that looks like that, okay? So for us, Mac users, and then I'll go through what this looks like for Windows to the best of my memory. I haven't used a Windows in quite some time. I'm gonna set up a macro. To set up a macro, all you need to do is enter the word global, and then I'm gonna give this macro a name called my data, and then I'm gonna add quotations and paste that directory that you just saw earlier. So what this does for the rest of our do file, once we run this command, Stata will remember that anytime we specify my data like that, we are shorthand saying this, right? And this is a really efficient way for us to be able to share do files across computers and things like that, because imagine you're reading in dozens of file names over and over and over again. Well, if you just have one directory macro up here, it would be really easy for you to give me your do file and me to replace this macro with where the data is stored on my computer and vice versa. So this is why we set up that macro in the first place. So for Windows users, I haven't forgotten about you. What you will need to do is you'll have your My Computer-esque setup or My Documents setup. And then once you go into the folder itself, so now you're clicking into the folder, you have those breadcrumbs right at the top of your screen that look like that. If you click in to that, I don't have an example to show you, but if you click into the breadcrumbs where you find the full file path, you can copy the file path from there and paste it into Stata, just like that. It's pretty easy to do once you figure out what this file path is, but this is always the hardest part of getting set up so that we all are on the same page. So let me just walk through that one more time, even though I know you have the recording. For Mac users, you've stored all your data in one folder, right? And it's loose in the folders. It's not in any subfolders. And you just go to that file folder, you hit copy, and then you paste into this directory macro that you just made. Okay, so just one thing that I feel like always gets students right at the beginning is you don't want to copy any of these files and their names and paste them in like this. You don't want to do that. You want to leave the file names for you to add in later on your own. So we have this set up. Now what we're going to do is we're going to test to see if our macro works. We are going to open up our first data set. Now, I decided to skip over the process of showing you how to import data sets from Excel, but it's actually pretty easy to do if you were on your own to find your own data sets. I'll walk you through what that looks like later. For now, I decided to just go ahead and get straight to the syntax so that I can teach you how to work with these data and manage them in the software itself. So students 2017 is one of our data sets that we have in our folder. So we are going to use this or load this into Stata by using the command use. And as you can see from the directions of this handout, I don't really recommend copying and pasting, especially when you have quotes, because it doesn't always copy and paste efficiently. It'll mess up the formatting and then Stata gets mad. Stata is very picky. So we're gonna write this just so. So once we run this, you will see that now we have variable names, okay? And we have some output from Stata. It just read in, so it ignored all this because we put it in our little brackets. And then I put asterisks up here so that it would ignore this first direction. And then it starts by setting up our directory macro and loading in the data. If we hit browse, which is that, it looks like a calendar or like an Excel sheet with a magnifying glass, you can actually see what the data look like, similar to how you would look at it in Excel in Stata. So walking us through these data briefly, what these data represent is they represent student level observations in a school district that provided sample data for us to look at, with variables representing the student's sex, their grade level, their race, their whether or not they are a migrant student, whether or not they are an English learner, whether or not they are in gifted and talented programs, economically disadvantaged, their ethnicity, their school code, and the year. So what we're now going to do is we're going to start our first lesson in managing data. And that's what we do when we have longitudinal data that we want to append on top of itself. We can easily do that by using this command append, using whatever data set we want to add to what we already have. Now, appending is literally stacking data sets on top of each other, right? So these data sets need to have the same variable names and they need to be formatted in the same way. And so what we can see by doing this with our other data sets and it is definitely okay to copy and paste in Stata itself, just not from Word documents. Is if you scroll over to year, we not only see just 2017, but we've also appended a new data set from 2018 and a new data set from 2019. So we now have 3 data sets that we have appended on top of each other in Stata with no errors. If you were to get an error in Stata, and maybe you have already gotten an error, I'm surprised I have not already myself, you will get some red text that may feel like it's yelling at you, but it's not. It's just warmly reminding you of certain errors that are in your syntax that you need to go back and fix. So one thing I should mention right now that you may have already noticed is if you are a Windows user, Stata can be really picky depending on the version you're working with these backslashes. So if you are a Windows user, it may be annoying, but you're gonna have to go through everything that I'm modeling for you and change these slashes to the other direction like this. But because Macs are superior, just kidding, because I'm using a Mac, I'm not going to do that for all of mine. Okay, let's go back to our handout. So now we are on step 6. We have the 3 data sets representing students. Now, when we are combining data sets and data sets that you may get from school districts, we often come up with our own conventions for how we want to label variables, rename them. One of the things I like to do with all of my variables is I like to rename them to be lowercase, right? And so you can do that by just typing in rename, whatever variable name you would want, and then renaming it. So as a reminder, this is the existing variable that you already have in your data set, right? We see ID right here or over here in the variable sidebar. And then we see year right here and over here. Now, I'm not going to walk through this right now, but you can go ahead and actually rename all of these variables to be lowercase if that's what you would like. Or sometimes what I like to do is some of these are very long. So I might rename gifted and talented lowercase GT, or economically disadvantaged lowercase FRL, standing for free and reduced price lunch, because that's the measure of economically disadvantaged that this district is using. And then the last thing that we're going to do in step 6 is we are going to destring year, comma, replace. What this does is it's going to change year, which is currently in our data set being stored as a string, to a numeric variable. You can look at what strings and numerics are being stored in Stata by just looking at how the values change colors based on what's being stored there. So kind of a rule of thumb is anything that is a number, for the most part, really should be read as a numeric variable. And anything that's text is going to be stored as a string variable. Those are the main 2 types of variables that I will be referring to, and we often refer to when looking at data and managing it in Stata. And we can see that that's the case in my browser window. We can see that data, for the most part, that's text is being stored as a string, indicated by yellow. For you, it may be red. And we have grade level, which has been turned into a number, and ID, which is a number. And then there are some other variables that probably should be numbers, but they're not. And so that's why, for the purpose of this lab, I'm going to destring year and make that a numeric variable, which is now what is on line 26. I'm going to run these 3 things. And if you look at Stata after you run that piece of syntax, you have ID has been changed to be lowercase, so has year, and year has changed to become a numeric variable. So I'm going to go back to our handout now. So now what we're going to do is we're going to merge in students' assessment data. So we have their demographic information. Now let's merge in their test score information. Now, merging is not the same thing as stacking data sets on top of each other. Merging is adding variables to a data set that you get from another data set that we want to add information to. So in this case, we have student demographics, and we have another data set that looks to be already appended because the name implies there's 2017 through 2019 data. And we're going to add that assessment information as new variables in our Stata. But before we get to merging, one of the key parts of merging is we need to be able to match this data set that we've just made with a data set based on unique identifiers. So in our case, we want to be able to match students and the year that we observed them in the data set based on their ID number and the year. And so one of the ways that's just good practice for us, and I'm just going to go straight to the command window, is we want to check and make sure that there are no duplicate observations. Or in other words, we are not seeing information for my student ID number multiple times in the same year, because these are the 2 variables we're going to use to match on. Oops. Duplicates report ID year. See, already made an error. So that command was just duplicates report, which tells Stata, tell me the number of observations in my data set that share the same ID number and year. And in this case, it looks like we do not have any duplicates, which is great because we don't want duplicate observations because that makes merging a bit trickier. So what looks like this data set is pretty good to go. Let's go ahead and save this. And don't forget to specify your macro, my data. And let's call it students underscore 17 underscore 19. And I always type comma and use what we call after the comma or options, use the replace option, just in case I want to come back up to the top of this do file and run this over and over again. A key feature of a good do file is one that you can make an error, 100 lines down, but you should be able to fix that small error and then copy everything from the beginning of the do file and run it again. So I'm going to highlight this in my do file. I'm going to hit the play button to run it. And you can see that now, if we go to our files, we have a new data set called students underscore 17 underscore 19. And this is what I mean when I say I want to be able to run this do file over and over again. If I highlight everything we've done so far, you should be able to run this over and over. And this is important because what if I wanted to come in here and I wanted to change one of the variable names? Let's say I wanted to rename all the variables to be lowercase, right? You could do all that and not lose any progress that you've made previously by just running it again. Now, this is going to affect other steps that I have listed in the lab so far. So I'm going to go ahead and delete this and again, rerun this so that I have the most updated data set in my files. You can also see on a Mac and Windows what date and time that a particular data set was modified. So that can always be really helpful just to check and make sure everything is saving as it should. Let's go back to our handout. We're on step 9. We are going to load in the assessment data. This is the last data set that we have not used so far in the lab. And by the way, as you're following along, if you want to leave notes for yourself on different steps in what you did, you can always just use this asterisk and leave notes just so that you can annotate and remind yourself of what you're doing. Okay, so let's load in our data set, our assessment data set. So in this data set, what you'll see, what we have is we have our student ID numbers again. We have the STAR data set. So STAR is the Texas standardized exam administered in grades 3 through 8 in reading and math. Occasionally, I think it's grade 8 in social studies and grade 4 and 8 in science. And they have end of course exams in high school, et cetera, et cetera. But we're, for this lab, just going to focus on math. But just so you know, within this data set, you also have the test date, you have the section of the test, you have the scale score, which is how we compare across years and across students. And we have the year that the test was administered. So let's go back to our handout. We're going to rename the variables to be lowercase as a best practice. So we're just going to use our rename command. Score is an existing variable that we have in the data set, and we're going to change that to lowercase score. Year is an existing variable. ID is an existing variable. Test is an existing variable, and section and test date. You can run that all at once just by highlighting. And you can see over here, just peeking in our variables window, that all the variables have been renamed to be lowercase. So now we're on step 11. We're going to destring that year variable again and test scores. And so with the dstring command, you can actually list multiple variables here. And the comma option, this replace, just tells Stata that you want to replace the values that are already existing in that variable. And now if you run that, you go back to your data set and you can see that score, which was a string, and year, which was a string, are now changed to numeric variables. This is going to be helpful when we want to descriptively explore some of these statistics underlying these variables. Now, let's keep our math scores. But when you're working with this later, I welcome you to explore different analysis on any given test score. So to do that, we're going to say keep if section =, math, in quotes, and shown by this ampersand, test =, star. So anytime that you specify if in your Stata syntax, you will always have to put a $. If you just do this, you will get an error that says type mismatch in the command window, and that's how you know, oops, that you need to have $. So if we run this and go back, you can see that we've restricted the data set down to just test scores in math. All right. So now I have a note here that just says, when you're dropping, observations down and reducing data sets, limiting your sample, you do want to kind of keep your workspace clean, your kitchen counter clean as you're cooking. I don't know what the appropriate metaphor is, but basically you want to drop the information that's no longer relevant, right? So we're not going to be looking at test date in our analysis. Ooh, that's an error. Do not drop score here. We just want to drop these variables that we aren't going to be using, or they don't hold meaning anymore. So the only section that's going to exist for us is math, and the only test that's going to exist for us is star, and we're not using test date. So if we just use the drop command and then the variables that we don't want anymore, Stata will drop them, and now you can see that we have ID, score, and year as the 3 variables. So now we've shaped this data set, cleaned it up nicely. So it's time for us to save. And so we're going to save. Don't forget your my data macro. We're going to call this assessments, keeping a similar naming convention, but adding that we've kept math scores. And now this new data set will appear in our OneDrive or wherever you are storing your data. Now, you may be thinking to yourself, oh my gosh, there's so much syntax. Like this is like having a, super law or a super intense, introduction to like, I don't know, a different language. And yes, it is totally normal to feel like that. But just so you know, Stata does come with some interesting packages that if you do need to maintain your motivation, if you all can install the Motivate package in Stata, SSC install Motivate is a third-party package that you just have to run once when you've installed Stata, and then you never have to run it again. And then go ahead and type yourself a Motivate so that you can get a Motivate quote to keep going. So see, it installed Motivate, and our quote for this workshop. I did not mess up the syntax. I just found 100 ways to specify it incorrectly. Now, you all are probably too old to remember a ton about Dolly Parton, but they're also, for those of you who are Dolly fans, a Motivate Dolly package with a Dolly Parton quote. I've had heartaches, headaches, toothaches, earaches, and I've had a few pains and, whoa, did not plan for this, but I've survived to tell about it. Y'all are in college, whatever. Thanks, Dolly. All right, we're back from intermission. Let's go to step 16. Woohoo. So now is time to merge. So even though you've asked Stata for your motivational Dolly Parton quote with an expletive and your regular Motivate quote, you still should have the data set loaded that we just left off with, this assessment data, right? So this, anytime you have a data set loaded in Stata, that is what we refer to as your master data set. It's what's loaded in Stata. This is relevant for this next step where we are going to merge data set and information together. So now let's combine our student data sets with our assessments. To do that, you use the command merge. One-to-one simply means that we have a unique non-duplicate observation based on the variables we specify, which is ID and year, in both data sets, the master data set, which is on what you refer to over here on the left, and the using data set, which is over here on the right. And a reminder, what that means is that we don't observe the same student in the data set in the same year more than once. And then you just specify the data set name, oops. Oh, what did I mess up? Let's look.
Shouldn't there be a merge using?
Yeah.
Oh, yeah.
Using.
There we go. And if you're following the handout, you knew that. Woohoo. There we go. I also like to make these mistakes on these recordings. I do this with my graduate students all the time because one of the things that I think can be really frustrating about learning how to code is if you come in with the perspective that you're never going to make a mistake. I mean, one, you're going to give up pretty quickly. And it's just helpful to think about, you know, just like as if you were working through a really intense math problem or whatever, that you're going to make mistakes. So I'm glad you get to see me be forgetful, even in my own syntax. Okay, so the handout asked you to take note about what matched and what didn't match. So after we run that merge, you can see that we have the three variables that we started with, ID, score, and year in the assessments. And then we have all those other variables that we were using in the students data set, along with this new variable that Stata made called merge. You will see students that were in both the students data set and the assessments data set be quantified here as the number of matches you had. So we had over 9,000 matches who were in both data sets. And then you will see non-matches here. And so in the handout, I prompt you to just think carefully about whether non-matches are okay, and if they are okay, who is in your non-matches. So in our case, what this means is there's about 3,700 students in the testing data set that had testing data, but no demographic information. This can be the case in some school districts where either students are new to the district and the district hasn't logged their demographic information, but they still are expected to take the test when the test is administered. And then for this using piece, this means that we had students in the students data set, but not the assessments data set. And that could be the case for in our STAR, since we're looking at the STAR data, that could be the case for 8th graders who are taking Algebra 1, because those are students who are not going to have a math score in 8th grade because they're taking the end of course exam. But it also could just be students who missed the test. They didn't sit for the test. And as a result, they don't have any testing data. So it just depending on your kind of research question and your policy problem that you're trying to solve, you'll just want to talk through to what extent you're comfortable with not having matches, or if you can mitigate this by improving something. Maybe there's an error in the data sets or something's not working right. But for our case, going to the next step, it's okay to just keep the matches. So we're going to say keep if merge equals 3. Because what this merge variable is, if you just use the command tab and then merge to see what the values of this are, merge just takes on the value of 1 for students who are only in the assessments data, 2 for the students who are only in the testing data, and 3 for the matches. So if we say keep if merge equals 3, that's going to drop all non-matches. We also can drop merge because now this only is equal to 3. So now we're on step 18. We can save our data set again. And we are done with data cleaning. One of the things I say a lot is that data management and data cleaning is over like half the battle, right? Doing the analysis and answering our questions once the data is in good shape is a lot. It's not easier, but it takes less time and maybe doesn't have as many headaches associated with it in getting syntactical errors. Okay, so we now have a data set. If we go back to our Stata browser, that represents a student every year, their math score, and then information on their sex, all the rest of their demographics, their grade level, and school. So let's start looking at some different things. Using some data visualization techniques. So this is also wrong. This just needs to be score, because now our score variable represents the math variable. Okay, so this first graphing command is going to look at the mean math score by grade level. So to do that, we're going to use the command graph bar to make a bar graph. Say we want the mean of math score, right? We're going to exclude 0 because that would be an outlier. It's impossible to have a 0 on the star unless you just didn't take it. Over grade. Oops. And even though this looks in the Word document like it's on multiple lines, you just need to type all of this on the same line in Stata, otherwise you're going to get an error. We're going to give it a title. We're going to ask Stata to label the bars. Now, it is not vital that you memorize all of the syntax that you're seeing right now. That's why I have it for you in the handout. And that's why I have it for me in the handout, because I often will recycle code and go back to doing things because I maybe don't have the mental faculty to be able to memorize the graphing code and data. So if you run this syntax just like we made, you will see, perhaps in different colors, because I think I've changed my default colors in Stata. You will see the mean math achievement with the scale score over here on the y-axis and grade level over here on the x-axis. And so in this case, we can see that the highest scale score is in 7th grade, which makes sense because if you standardize the assessment across grade levels, 7th graders should be doing better content-wise than the lower grades. One interesting thing here, though, to note from the 8th grade, remember what I said earlier about 8th graders, if they are in Algebra 1, do not take the math achievement, the regular star. So 8th grade, one thing you might be asking here is who is in that 8th grade sample? For us, it's going to be students who are not on the Algebra 1 in 8th grade track. So students who are on the lower math track. So that kind of makes sense. If we were including those Algebra 1 students or those who would be in Algebra 1 in these other years, it makes sense why we're not going to see as high of achievement, because we're taking all of our Algebra 1 takers out of the sample in the 8th grade. So just if you're curious. You can save that graph, you can go back, make edits to it manually, you can play with these different settings right here, call it a different name, look at this different formatting code of what this does. But now what I want to do is, let's say and this is where we get into education policy research, right? We now can come up with questions related to math achievement with this particular data set and how this differs maybe for students who are economically disadvantaged. It is often a priority for education policymakers to mitigate achievement gaps that we see by grade level. So one way that we might go about doing that is taking this very similar code. So I'm actually going to copy from my Stata window. And I'm going to add a few things to it. So we're still going to have it over grade, but now I'm going to come over here right after the over grade part, and we're going to add by parentheses economically disadvantaged. You can see why it's helpful to rename variables smaller names, because it can be tedious to type later on. And then I added a comma. I did not close the parentheses. I'm going to leave this title, all this still in that parentheses. I'm going to close the parentheses at the end of title. So over here. And this is because otherwise it's going to give us it's going to treat it as two graphs that want two different titles, and we don't want that. And then you can specify a range of the data if you want. So the R range, let's say we want to look at it. Oops, I missed something. There it is, range. Let's say we want to look at it for those scoring 1400 to 1800. If you run that, you get math achievement for those not economically disadvantaged and those who are economically disadvantaged, indicated by the N and Y up here, and then the scale score by grade level. So as you can see, in every grade except for 8th, which is a funky grade to look at anyway, our non-economically disadvantaged students are scoring much better than our economically disadvantaged students in this particular district. The exception would be in 8th grade. And that 8th grade year is going to be a little wonky because, again, it doesn't really represent the whole district. But in this case, somewhat interesting that in the sample of students who are not in Algebra 1 and thus are taking the 8th grade Math STAR assessment, those who are not economically disadvantaged are doing quite poorly on average. All right, so that is what I have for you for this workshop. There are so many different things that we could talk about in terms of answering interesting research questions in education policy, but this is just meant to be a taste of the type of research that we do to answer, various questions. But one of the things, since you have access to these sample data sets, and I will provide my do file so that if you don't want to walk through typing all this out by yourself, you can just open this and change your macro up here to wherever you have the data and you can run this. I encourage you to look at different things, right? So you could go through this whole do file again and do the same thing, but for reading assessments, right? So think about what part of the code could you add to this at the bottom by copying and pasting, and instead of keeping math scores, we keep reading scores, right? All right, so that's all I've got for you. Like I said, play around with these different data sets and think about different questions that you could be asking and how you might go about doing that. If you are interested in this type of stuff, you like the idea of coding and learning this pretty tame coding language, working with me or others who are doing education policy research with quantitative data is a great way to get this experience. So I encourage you to stick with it. And as a reminder, if you ever get discouraged, there's lots of motivate commands that you can use to keep you going. So thanks everyone for participating in this workshop, and I hope to see you all again soon.